Hello and welcome to our tutorial regarding our phase noise and jitter design tool. We will start with a quick introduction before we continue with an overview of the tool and finish with the use case. Let's start with the introduction. You will find the phase noise and jitter design tool on our website at hokua-rf.com. Go to the section Design Tools and click on the category RF Systems. Here, you scroll down and select the tool. Let's continue with the overview. At the top, you have to specify the oscillator frequency before you enter all available phase noise data. Afterwards, you may define a reference frequency that is used to scale the phase noise data. You will find the correction value immediately thereafter. The first diagram depicts the entered and possibly scaled phase noise data, while the second diagram depicts the piecewise integrated phase noise of each entered frequency segment. This is very helpful information when you have to improve an oscillator's total integrated phase noise and you need to know which frequency segment contributes the most. Afterwards, you specify the integration frequency range that is used to calculate the total phase noise power and the resulting total jitter. The references are an excerpt if you want to dig deeper into the mathematics behind the phase noise to jitter conversion. Let's finish with the use case. We would like to present a comparison of the phase noise performance of three different types of oscillators. The first problem is that all oscillators operate at a different frequency. Second, the phase noise data, which is obtained from the respective data sheets, are not only given for different offset frequencies, but also for different frequency ranges. Let's use oscillator 3 as the reference oscillator, for which we already have the total integrated phase noise and jitter from the data sheet. All available data is summarized in a single diagram, including the integration frequency range, which is defined to be 12 kHz to 20 MHz for the application at hand. We have already entered all phase noise data in our design tool. At the top, you have the operating frequencies of oscillator 1 and 2, followed by the respective phase noise data and the reference frequency, which is the operating frequency of our reference oscillator. The phase noise diagram will indicate how the design tool will extrapolate missing phase noise data if the integration frequency range is larger than the available phase noise data. The total integrated phase noise power and jitter are calculated thereafter. Now that we have all phase noise and jitter performance data, we can conclude our oscillator comparison using oscillator 3 as the reference. It is not surprising that the crystal oscillator 3 has very good phase noise and jitter performance. However, other performance criteria, such as long-term frequency stability or possibly acceleration sensitivity, might also be important design parameters. Our design tool, however, can be used with a multitude of objectives. You may not only compare reference oscillators if you are looking for a second source or an optimum design, but you may also evaluate low phase noise amplifiers, assess the impact of clock drivers, or estimate the effect of different components in a complete synthesizer design. We hope our tutorial was helpful to you. Thank you for watching and have a good day.